So on number 8, which ordered pair is in the solution set? Well, to be a solution, that is where the shading crosses. So notice we have this side shaded, and then we have this side shaded. So anything where the shading intersects, so from here, here, anything in this area is what we're looking for. And this goes on forever. And so then I start plotting my points, and they say 1, -4. So I go plot 1, -4, which now I can't see anything. 1, 1, 2, 3, 4. Looks like 1, -4 is in there, right? And then -5, 7. One, 2, 3, 4, 5. -7. It's almost in there, but not quite. It's almost in there, it's just right off the line. So it's barely not in there. And then 5, 3. See 5, 3. Starting here. 1, 2, 3, 4, 5. 1, 2, 3, right there. So that's not in the green area. And then the last one, -7, -2. 1, 2, 3, 4, 5, 6, 7. 1, 2, right there. That's not in the green area. So there was only one coordinate that was in the green area, and we call that the feasible region. So this was a fancy way of saying which coordinate is in the area where the shading intersects. So I'm supposed to determine the solution to the system. Now there's not going to just be one solution, because we have a less than sign and we have a greater than sign. Actually, that's less than or equal to, that's greater than or equal to. So there's going to be quite a few solutions. This would be like me saying, give me a number bigger than 4. Then you would say 5, you'd say 6, you'd say 7. So with inequalities, there's multiple solutions, and that's what the shading is for. So in order to solve this, I need to put it in the form y = mx plus b. So I'll start with the first one. Copy it down. I want y by itself, so I'm going to minus x from both sides. And I get y is less than or equal to -x plus 1. So I'm going to graph the boundary line. The boundary line would be y equals -x plus 1. So where do I start? I start at 1. And then this says to go down 1, right 1. And I continue to follow that pattern. On both sides. And technically, to make a line, you only need 2 points. But I like to draw them all out. It makes it easier to make a straight line because I have more dots to connect. Or you can use what some people call a ruler. Now from there, this symbol right here If it's less than, that means shade underneath. So I'm going to take all of this and shade it underneath. So all of these are solutions to give me something that's less than negative x plus 1. All of these are solutions. And it goes forever. Okay. Next, we're going to take the other equation. One thing that might help is this handy table. So you solve the inequality for y. You graph the boundary line. That's what I've done so far. Now in my problem, I made it a solid line because we had less than or equal to. If it had just been less than, you would have used the dashed line. And then here, you're going to shade above for greater than or equal to, and you're going to shade below for less than or equal to. Ours was a less than or equal to, that's why I shaded below. Okay, so I need to go and copy down my next problem, which is x minus 2y is bigger than or equal to negative 6. So I need to solve for y. First thing I would do is minus x from both sides. And you get negative 2y is bigger than or equal to negative x minus 6. Then divide by negative 2. And any time you divide or multiply by a negative number, what's going to happen is this is going to flip around. So instead of greater than or equal to, it's going to become less than or equal to. And that's only if you divide or multiply by a negative number. If you add or subtract a negative number, it doesn't do anything to it. And then negative divided by negative makes a positive, so that'd be same thing as 1/2 x. And then negative 6 divided by negative 2 is 3. So from there, I start at 3. And then I'm going to go up 1 over 2. And then also the same pattern the other way. And then I ask myself, is this going to be solid or dashed? Well, it has an equal sign, so it's solid. And then less than or equal to, I'm going to shade below. So I'm going to take this and shade below. Now you can see where the shading intersects, that's where the solutions are. So if you could tell it from your graph, which I can, that the solutions are anything that's around here. So I'm going to call that FR. The feasible region is anything on this section. So if someone said, is 0, 0 solution, you would say yes. Is 0, negative 5 a solution? You would say yes. Is negative 1, negative 3 a solution? You would say yes. If I picked any point over here, it would only work for this one. And if I pick a point over here, it only works for that one. And if you pick a point in here, it doesn't work for any of them. So it's all of these points are a solution. It works for both. So question number 1, it says, tell whether the ordered pair, this is what we call an ordered pair, is a solution of the given inequalities. So to be a solution, that means when I plug it into both of these, we get true statements. So let's test it out. So first, let me write down y is less than x minus 3. And let's plug in, and remember this is x comma y. Let's plug in negative 2 for y, so that'd be negative 2. Is negative 2 less than x, which is 2, minus 3? Is negative 2 less than negative 1? Yes. So if someone said, is this ordered pair a solution to just this inequality, you would say yes. But in order to be a solution to the system, it has to work for both. So now we need to plug it into the other one. And the other one is y is bigger than negative x plus 1. So substituting y is negative 2. Is negative 2 bigger than negative x? X is 2, so that'd be negative 2 plus 1. And negative 2 plus 1 is negative 1. So is negative 2 bigger than negative 1? No. So because I did not get true statements on both of them, I would say no. 2 negative 2 is not a solution to the system. Here's another way you can see if it's a solution. Notice I took the problem from before. So I took this problem and I graphed it, and anything in this darker area is what we're looking for. So any point in this dark blue will be a solution. So the question was, is 2 negative 2 a solution? Well, 2 negative 2 is right there, which is, that's why it worked for one but not the other. So I would say no, it's not a solution, because to be a solution it needs to be in this area. So number 5. If we look at this, 1/2 x plus 1, it's already in y equals mx plus b form, so I start at 1. And then I go up 1 over 2. And I continue the pattern. But then I ask myself, is it solid or dashed? And I notice it has an equal sign, so I'm going to do solid. And my line is not very straight today. Sorry about that. And then I see that it's less than, so I'm going to shade below. So I'm going to shade below, and I think it's easier to see through a highlighter, so I'm going to shade below. And that's my way of shading without coloring it all in. Other one, x plus y is less than 3. We need to isolate for the y. Not too bad. We just got a minus x from both sides. And I get y is less than negative x plus 3. So I'm going to start at 3 this time. And negative x just means go diagonal to diagonal, corner to corner, negative 1 over 1. And I'm going to continue to do that pattern. Then I ask myself, is this solid or is it dashed? And I noticed it doesn't have an equal sign, so I need to make this dashed. That's very important. That means that any point on that line doesn't work. And this goes forever. And that goes forever. So y is less than negative x plus 3. That would also be underneath. So underneath, because of the less than, would be this side. So it looks like my feasible region is over here, in this section. And this goes forever. Now the second part of the question was, give two ordered pairs that are solutions. So I'm supposed to, for A, I'm supposed to put two ordered pairs that are solutions. Well, I can pick any point I want in here. Let me pick 1, negative 2. That's a solution because it's in the area where the shading crosses. Another one I could pick would be 0, negative 9. And I could write these forever. There are an infinite amount of solutions. Now B was give two ordered pairs that are not solutions. Well, definitely anything up here is in a solution. So I'm just going to put a random point there. That is not a solution, and that is 2, 8. And then I could pick another point, or I could pick a point here or a point there. All of those are not solutions. I'm just going to keep it simple and pick 0 or 2, 7. So 2, 7 also is not a solution.